And for those of you guys that know me personally know, I used to do a lot of sheet metal and manufacturing in my previous life. And so this year we're actually highlighting a really, one of my favorite customers that we have is a company called Omax. And they're a manufacturer of water jet machines for everything from sheet metal to billet cutting material. The first thing I want to start off with is what I like to always begin with, and that's sketching. So last year we introduced touchpad and interface. This year we've taken that even further. Now inside SOLIDWORKS 2020, when you're using a touchpad, you can input a dimension directly into the modify box, either leveraging a stylus or even your fingertip. Along with that, most of you guys might be familiar with mouse gesture. Now there's a very similar command inside the touchpad that's going to give you access to that, and that's called power modify. The way power modify works is by using either your finger or a stylus, you can make a variety of different little gestures on your screen. For example, if I were to drag my stylus in a U through a line, it would trim it. If you drag a straight line through a vertex, it does a chamfer. And if you were to create an arc through a vertex, it's going to create a fillet. You can also do an X motion, and that'll split an entity, or do a straight line motion with the stylus, and that'll trim an entity back. So again, power modify is very similar to mouse gesture. It gives you a lot of your common sketch tools when you're working on a touchpad right at your fingertips. In this case, you're going to see me do a double parallel line, and that's going to offset my geometry where I can then put in a dimension. To wrap this up, we'll go ahead and extrude cut out that speaker, and then we'll be done with that and ready to move on to the next step. Now, the next thing that we're going to look at is we're going to look at some really awesome new sketch relations inside of SOLIDWORKS 2020. The first thing I want to do is I want to do a little bit of analysis on the outside of this part. And so to do that, I'm going to turn on zebra stripes, which isn't anything new. What zebra stripes gives you the ability to do is to see where you have continuity. And in this case, I have an arced face and a flat face. And I can see that these zebra stripes aren't matching up. They're not parallel, and they're not flowing evenly through that vertex. What we've added inside SOLIDWORKS is now when I edit this sketch, and if I look at this sideways, you're going to notice I can see that continuity here. Well, hopefully you know that you can add a relationship by clicking on a vertex. But there's a brand new relationship that you're going to see, and that's called G3 continuity. Okay, G3 continuity is like a tangent relationship on steroids. By simply clicking this on, that keeps that curvature constant through that vertex. So now that straight line and that arc is now maintaining a smooth curve all the way through that. You can think of that almost like a fit to spline. So we're eliminating a lot of extra steps. Now when I rotate this around, you'll notice that those zebra stripes are evenly distributed through that entire face, through the entire part. So that's called G3 continuity.
I made a mistake, I mean it's been weeks ago, but I made a mistake once and used the undo command. Maybe you've done that. I've seen people in the Essentials class actually make a mistake before and hit the undo command maybe one too many times. Got a little frustrated. Pretty soon you've undone your way all the way out of the sketch, and you've lost that sketch information, right? Or any changes you made to that sketch. Well, in 2020, the redo command has been made more powerful, so I can redo my undos all the way back through a sketch, or into the sketch and through it, and all the way back out, to where I don't lose any information when I use the undo command. I can redo it, and so there I'm back to where it was. So just save you from having to do a little rework there. Making edits is just part of the design process. After 30 years, I've never designed a part right the first time. At least the customer, if I thought it was right, they had a change to make. So the beauty of SOLIDWORKS is its power in editing. And so I need to edit this part to add a second configuration that doesn't have these cutouts in the middle. This person, though, that designed this didn't take my Essentials class, and they modeled the cutout and the boss in the same feature, which is a matter of preference, but I'm going to have to edit this feature now to split that up into a boss and an extruded cut, so then I can suppress that cut in one of my configurations. So there's my boss. I'm going to grab that sketch and share that sketch in an extruded cut through all. And there, now I've got two features, and if I need to, I can, in my second configuration, I can now suppress that cut. Now you're saying, what's new about that? there's nothing new about that. We've always been able to do that. We've got a lot of powerful editing capabilities, and as expected, the holes rebuild as I'd expect. Now, even though this geometry has not changed, I just changed my design tree, but geometry hasn't changed, but all the edge references have changed. So this fillet fails, and you've probably seen that. You get that fillet, red X next to your fillet, and you come in here and you've got all these missing edges, right? So you've got to go re-pick all those fillet edges in 2020 and just right-click and choose Repair All Missing References. And SOLIDWORKS does the work for me, re-picking all those, saving me a lot of time on making edits. So less time editing, more time focusing on new designs.
A very common workflow that people use these days is getting neutral files from other places. How many of you guys have ever downloaded something from the internet, right? Or how many of you guys have ever scanned something, reverse engineered something, or have a vendor or customer send you a model that's not SOLIDWORKS? I know that's a crazy concept. Who out there is not using SOLIDWORKS? Not sure, but they're not thinking, right? In this case, I actually have an STL file. And maybe I'm going to print this STL file, but before I print it, I need to make some changes to it. Now, what's the problem with an STL file in SOLIDWORKS? You can't do anything into it, or you couldn't do anything to it. We've changed that. You now have access to a lot of the common tools that you're used to using, so you can now modify an STL file with actually not having to recreate it totally from scratch. So let me give you some of the design scenarios. In this case, Omax, they got this from a vendor, and the vendor forgot to fillet all these top edges. So guess what I can do now? Here's my STL file. I'm going to come in here. I'm going to add a 2mm fillet. I'm going to grab the edge of the STL file. I'm going to grab this edge of this STL file, of this edge, and I'm going to hit OK. I can modify it directly. Maybe I change my mind and I decide that that fillet, I don't really want it to be a fillet. I want it to be a chamfer. I can edit that fillet and turn it into a chamfer. Another thing that they messed up here is that this is a little collar of some sort, and a shaft is going to sit on there, and they have it sized the wrong way. So I want to leverage that geometry. So what I'm going to do is I'm going to come in here and I'm going to tell it to offset the inside of this 10mm going in. So now I'm leveraging a piece of geometry of this STL file. Now, just so you can know what I created, I'm going to isolate it. So I just took that top face of it and I just offset it 10mm in. Now I'm going to use this as a trim, which is a surfacing tool. But before I do that, I want to extend this out so that way you guys can see it very clearly what I'm doing. And I'm going to extend this out at simply 5mm. So what I've done is I leveraged a piece of the original file that my vendor sent me. I've now offset it 10mm inward. And now I can treat this STL file as like a surface, and I can do a trim. So what I'm going to do is I'm going to come in here and I'm going to do a mutual trim. That's where I'm taking two surfaces, and in this case I'm going to remove a portion of the original, and I'm going to remove a portion of the file of the surface I just created, and then I'm going to hit OK. Now I've directly manipulated this where traditionally we could never have done that process. We know that when you bring in a neutral file, sometimes we get little anomalies, right? And how annoying can that be? Has anybody ever brought in a neutral file and you have like a little bitty hole and then you try to cut it or do something with it and you're like, man, this thing is hollow. It's not really what I need. Well, if you didn't know this, there's a tool called Check Geometry. When I come in here and I choose Check, it'll evaluate this, and I'll notice I have one open surface. And I can see that that surface is down here on the bottom. So if I come over here and click, it actually puts a big arrow. That's not anything new. Evaluate. What is new is how we clean this up. So traditionally, I would have to go and regenerate and remap this surface on that little hole. What you're going to notice now inside SOLIDWORKS 2020 is if you right-click on the edge of that hole, you're going to see an option called Delete Hole. What that's going to do is that's actually going to delete that and mesh that hole back together, creating a brand new surface for me. Ordinarily, I would have had to do that from scratch, like with the surface loft or a fill or some complex set of features. On top of that, let's kind of leverage that same process here. And I can see they had some mounting holes that I really don't need anymore in this design. So I'm going to come in here and actually do a delete face. Again, you'll notice that these aren't new tools, but I'm having access to them when working on this imported STL file. When I hit delete face, you'll see the option delete and fill. We're going to hit that green check mark, and now I flatten that face out, and now I have a nice clean body. And if I even cut this out, you'll see it's now a solid body that I can then send over here to my printer, and I'm ready to go. So I think that's powerful because that's something that we're seeing a lot more people do these days is leverage stuff outside of your own department, getting information from other places. So we're making it even easier for you to manipulate. Another very common thing that we're seeing people do is reverse engineer parts, right? We know sometimes maybe there's a part or something you need, you can't get access to it, or maybe it's just too expensive, and you say, hey, I can improve on that. One way that a lot of people do that is they scan a part, or they might probe a part. Along with being a mess, there's a lot of what we call facets. That means when you scan something, it's taking a bunch of points, and it's not like creating a surface in SOLIDWORKS where it's just this nice, flat, clean surface. The challenge is if you don't have robust hardware, sometimes your machine might not be able to handle the scan. So what do you do with it then? Right? Nothing, right? In this case, what you're gonna see here is I have a scanned part. It's the scanned gear that I need to reverse engineer. First is I can now do direct manipulation on the scan. Second, the tool that I wanna show you is if you right click on the scan, you're gonna see a new feature called Decimate Mesh Body. That just sounds good. I just like the way that sounds. Decimate mesh body. Say that a few times and you just sound really intelligent, right? If I see my boss walking by, I'll just throw that word out and he thinks I'm doing something pretty fancy. In this case, if I choose decimate mesh body, in the properties manager on the left, it's a pretty simple interface. All it's asking for you to do is to reduce the amount of facets on the face. On the model. In this case, if I tell it to reduce the facets by 50%, you'll see it's going to drop this down from 250,000 to 125,000 facets. Now, what does that mean for you, the end user? That means it's going to be easier for you to actually modify and work with. On top of that, I can now leverage this scan data much more efficiently. So for the sake of the time, I actually recreated some of the information in a native 3D model that is more conducive of me and my manufacturing environment. Now, the next challenge that OMAX ran into was they said, hey, we reverse engineer some of these parts off a scan, but we want to know, or we want to have a relatively good feeling that the part we reverse engineer in our CAD is similar to what the scan is, right? Now, think about it is I want to transpose these two things on top of each other. If I come up here into the Evaluate tool, you're going to see a brand new feature called Body Compare. What Body Compare does is it gives you the ability to choose a source body. In this case, my source body is going to be that scanned image. Then it's going to ask you for a compare body. That's the body that I reverse engineered. In this case, that's going to be this little gear that I just modeled up. When I hit confirm right here, I'm actually going to isolate this body so you can see what's going on here a little bit better. It's creating a heat map and color coding that body, letting me know where I'm dead on or where I might be missing or adding a little bit too much material. In this example, you'll see the fact that right here I have blue, and blue, if you look at my legend, means that I have more material than what was originally in the scan. Where it's red, that means I'm missing some material from where, that means that the scan was indented from where my part was. So for me, I can look at that real quickly and say, man, I'm really close to my reverse engineered part. And that's probably, I'm going to chalk that up to an anomaly in the scan, right? Maybe the scan didn't come in perfectly. But now I know the key important features, for example, the inside hole of the shaft and the profile of the tooth are really, really close because they're totally green. Where before I might print this out and then have to physically go do it. So now I have a really good idea that my reverse engineer part is pretty close to being ready. Now the last thing that we're going to talk about with this complex geometry is here I have a surface. And I'm going to go ahead and offset this surface. The challenge for OMAX in this case is they wanted to leverage a cover of a motor from one design to a new design. But in the new design, the cover needed to be a little bit larger. So let's expand this out without having to remodel this up from scratch. So I'm going to come in here and I'm going to do an offset surface. And I'm going to grab this and we're going to offset this surface, let's see here, 5 millimeter. I'm going to hit the green check mark. And then SOLIDWORKS hates me, so it gives me this. How many of you guys have ever tried to offset a surface or maybe shell something out and it tells you, I can't do this? You're like, yeah, I've mastered that feature. My man Jeremy over here has it down. If you need to know how to do that, he can teach you how to blow up an offset. Let me explain why this does this. When you offset something, it has to be able to create the geometry in the new location. If you scroll in, which I know where the problem is, you can see this fillet. I'm offsetting it too much. That fillet can't get recreated where I'm telling it. The problem with that is inside SOLIDWORKS, the feature would ordinarily just fail, which means that you would have to go in there, identify those faces one at a time, and then offset them one at a time, and remesh everything together. Now, what you'll notice is if I come over here, I can just tell it to continue to offset it. Just don't try and offset the faces that are going to fail. Just keep on working. Leave the failing faces alone. All the rest of the geometry that's good, go ahead and let it get created. Now what happens is I have two surfaces. I have this internal surface and I have this external surface, which makes it real easy for me to go and recreate those missing or failing fillets. In this example, all I got to do is just trim them to each other. So I'm going to grab them two. I'm going to go ahead and tell it to keep, and I'm going to keep them. So now I've took those two offset surface and put them back together, and then I can finish my design and put the fillet that was failing right back into the actual design. And in this case, that fillet size we're going to say is going to be 10 millimeter. Once I have that, we'll hit the green check mark, and now I've taken my original surface that was not completely ready to offset in that same 5 millimeter distance. I've offset it and I've recreated that fillet. To wrap this up, since this is a surface which is uniformly thin, it's indefinitely thin, meaning there's no physical size to it, I want to go ahead and thicken this. And the way that we do that is a tool called thicken. What you're going to see new for 2020 is now I can do what we call a mid-plane thicken, which is essentially adding material to both sides at the same time. And in this example, we're going to tell it to just do a 2 millimeter thicken both ways. So it's adding a millimeter in, add a millimeter out, and now I have my cover ready to go. So we're trying to make it a lot easier for you guys to leverage all your complex geometry and your complex tools inside SOLIDWORKS 2020. Now, a big design challenge for OMAX was the cutting head. The design challenge on the cutting head was the fact that this thing is putting a high pressure liquid that's mixed with sand essentially. It's like sandpaper. And the problem is as that splashes up, it's corroding and it's messing up key components inside of this subassembly. At the same time, the subassembly needs to stay flexible. So the way that OMAX addressed that was to add what we call a bellows. In this case, I'm going to go ahead and turn these on. Now, the design challenge with that is when I'm looking at this inside SOLIDWORKS, this is a part, and we know in real life this part flexes. So if I were to move this, it doesn't give me a realistic representation of my assembly. So how can I address that? So that way when I'm actually doing an analysis on this or looking at the motion of this, these parts stay fixed. There is a feature that we now have at the part level. This feature used to be a subassembly level. So anybody ever use Make Subassembly Flexible? Anybody ever use that tool? When you turn that on, essentially what that does, if you've never used that, is if you have a subassembly and it had motion in it, it'll let you leverage that motion in a top level assembly. Okay? Think of like a shock absorber. You can now leverage that at the part level, believe it or not. It sounds crazy. It's called Make Part Flexible. So what I'm doing is I'm telling this bellows, essentially, you can think of it mating to that cylinder. When I made it to that cylinder and I hit this green check mark, now when I move this, remember this is a part, it's not an assembly. When I move this and I let go of it, it's going to rebuild itself and keep it mated there. Now you used to be able to do this, it was just a very complex workflow. Sometimes it might take you a couple extra configurations, maybe not 100 configurations, but a few extra. In this case, I can now leverage Make Part Flexible to streamline that process. Now, here's what's really neat about this, is I have a left and a right-hand version of this bellows. Now, this would be next to impossible previous to 2020. I'm now going to come over here, and I'm going to right-click on the right-hand side of this part. I'm going to tell it to make it flexible, and we'll add the new reference on this face. So it's the same part, opposite side, and now when I drag this around, I can see that both of these parts are now actually glued and fixed into that part, giving me a realistic representation of this flexible component. That might be a little bit to digest, so I have a simpler example here to kind of show you what this looks like. So same bellows system. You'll notice if I drag this up, it readjusts. If I drag this down, it readjusts. So now when we're creating these complex systems, we can do this much more efficiently without having to leverage a lot of crazy design content at the part level. You can also see this, and I'm a sheet metal guy, so I used to do this a lot, with things like living hinges, right? So that hinge is a hard plastic part. We know that it moves. And so as I move this part, we can see that that part is now a flexible component. If you're like me, I like living in the 3D world, but I know that drawings are still a necessary evil that we have to address. In this example, what I'm going to do is I want to come in here and I want to change the scale of this. Now, for us old-time users that have been in SOLIDWORKS some time, we know that we can go to the sheet properties. So if I come in here, I might change the scale globally in this entire drawing 4:3. But what I want to show you now is the fact that you can access your scale directly from this flyout menu. You can access all your default scales right there, or one of my favorite things is being able to user define this without having to actually get all the way into the view property. So in this case, I really wanted that to be scaled at 2:3. Now, one thing that used to always eat me up is I have a lot of scales that I use that aren't part of the default in the system, right? So if you're not using something that's standard and they're like 1:1, 1:2, quarter scale, you can now predefine your scales on what you want to see. It's done in a text file in your options, system options. So here you can actually notice that I'm putting in my own custom scales that I'm using most commonly. Now, the last thing I want to show you in this drawing view is a brand new dimension scheme. Now, before I do that, let's go ahead and create a little detail view. When I create this detail view, I know by default, SOLIDWORKS uses a 2:1 scale. So if you didn't know that, when you create a detail view, it defaults into 2:1. What you're going to see is a lot of times that's not really what I'm looking for. So now I can come directly over here into my properties and I can actually give it the scale that I want. In this case, I'm going to scale this 1:1. It used to be a little bit annoying. You would have to place that view, come back into the properties, and change the scale. Now I can just do that directly in my properties manager as I build a view. Now, the new dimension style that I'm going to show you is called a chain dimension. And this is something that I do quite frequently. What chain dimension gives me the ability to do is to choose essentially a baseline, a starting point. Then I'm going to choose an edge, and I'm going to continue to choose edges. As I choose more edges, you're going to see it chains all these edges together, and it's creating a display style called a chain dimension. It's very similar to an ordinate, pretty common dimension style. The cool thing about this is it actually has a lot of intelligence. So if I were to delete one of these dimensions, you'll see that chain automatically update. On top of that, a lot of the times I want to take a chain and add a specific dimension to it, for example, my overall. So if you click on any chain dimension, you can add to overall, or in any chain dimension, you can flip it from a chain dimension to a baseline dimension by simply telling it convert to base. Now, the last thing that I need to do in this drawing is I know that this pump housing for OMAX needs to get machined because it comes in as a cast component. Now, a lot of the times when we're creating things or manufacturing things, there's many manufacturing processes that we need to account for. In this drawing view, I want to show my machinist the actual amount of material that they're going to be removing off the cast component to the finished machine component. Previously, a lot of times I would do is create multiple views of 2 different configurations. But I want to make this a lot easier for the end user to consume. So what I want to do is I want to show you how to use a view called alternate position view. So I'm just using my shortcut key, by the way. That's S, standard shortcut in every seat of SOLIDWORKS. In here, there's a tool called alternate position view. How many of you guys have ever used that right now? Anybody ever used that before? Oh, a few of you. Let me explain what it is in case you didn't know. Alternate position view is actually an assembly tool. If you had an assembly, like say a cabinet, and you wanted to show the doors closed and you wanted to show the doors open in the same view, that's called an alternate position view. It'll superimpose those 2 views on top of each other, but it would do it in an assembly. This isn't an assembly, this is a part. I want to show the cast on top of the machine part, so that way I can put a dimension between the cast face and the machine part, and now my machinist knows exactly how much material it'll take off that cast component. So now you have access to this at the part level. Once I choose alternate position view, I choose the view that I want, and then it gives me access to the configurations of this part. In this case, I have 2 configurations. I want to show the casting configuration. So what I want you to do is pay attention to this view right here. Watch what's going to happen when I hit this green check mark. When I hit that green check mark, it superimposes with dashed lines the cast configuration on top of that. Now I can come in here and I can show my machinist, who really needs to know this dimension, exactly how much material he should be looking for to remove off of this component. In this case, it's going to be 3 millimeters on both sides, and I'm even going to give him an overall size so that way he knows how big this thing is when he's looking for it. So we're leveraging and we're giving our end user a lot more detailed content in an easier form for them to digest.
In simulation, we've got a number of enhancements that for the most part, speed up our ability to run simulations. The first being the ability to use a mixed mesh. So what that means is on areas where I'm not really concerned with the stresses, I can use a draft quality mesh because they solve really quickly. Other areas where I'm really concerned with the stress results, I can use a high quality mesh. And so that's going to allow me to solve more complex assemblies quicker and still get those stress results that I'm concerned with, you know, really detailed results. And so I'll show you that here. To do that, I can just right click on an item and change it from high quality to draft quality, or from draft quality to high quality, just with a single click. So any items I'm really concerned with, I'll just swap them over to high quality. You see your design trees can get really long and cumbersome here. With a Shift C now, you can collapse your entire tree with just a click, so it's more manageable. Also from the tree, I can access my simulation evaluator. So that's a new tool. It's basically providing a lot of information about my simulation all in one spot. So I can see where my results are being stored. I can even reattach a result file from another location back to this study. I can see a list of all the materials being used in the study. I can even get a comparison between the mesh geometry and the geometry of my SOLIDWORKS model to make sure that my mesh is accurate enough and I'm getting a quality result. So a lot of information in the simulation evaluator, kind of give you a sanity check to make sure you have your study set up correctly. Down at the bottom, I'll get a lot of design, different design studies running. And if I get one that I don't need, I can simply right-click on it now and delete it without having to first load that study. So I can clean those up a lot faster now. Another thing I can do is use beam elements in my thermal studies, and I can apply temperature loads to beam elements. So even though we can do mixed mesh now, we can do a high quality mesh and a draft quality mesh in the same study. When we have sheet metal parts, it's still really beneficial to use shell elements and use beam elements when we've got long cylinder parts. Well, now I can have a beam element and I can go apply a temperature load, for example, directly to that beam or to the beam joints. That's something I couldn't do before. I can also run a thermal analysis when I have beams in my study. So in a thermal analysis, I can go in and apply all my thermal loads, my convection, radiation, conduction loads, all of these directly to a beam. So, and once I'm done with that thermal analysis, I can import the resulting temperatures from that thermal study into my stress study to do stress analysis to see how those changing temperatures affect the stresses in my part or the displacement in the part. So that's something we couldn't do before with beams, so we're going to be able to use beams in more studies, and beams are super efficient when doing these studies, so it lets us get to our results really quickly. So the mixed mesh is one of my favorite enhancements. Another one in simulation is the improvements to the pin and bolt connectors. So if you've ever used pin and bolt connectors, they allow you to simulate like a bolted connection here without having to model the actual bolt. So it saves you modeling time, and probably more importantly, it saves you from having to mesh that bolt. But an unfortunate side effect of that is that bolt is perfectly rigid and makes perfectly rigid to that surface, and you end up with some unrealistically high stress hotspots where you're using bolted connectors. Well, in 2020, they've improved the bolt and pin connectors to let you create a distributed connection instead of a rigid connection. And I'm going to show you a comparison between the two. The distributed connection allows that face to actually flex a little bit like it does in real life. I'm going to use the compare results tool, and I'll compare the two studies with the rigid connection and the new distributed connection. At the top here, you'll see the old rigid connection bolt, and you'll see those stress hotspots that I kind of got to explain away in the past. Now below is the distributed connection. It gives me a real really realistic stresses even when I'm using that bolt connector. So that's going to allow me to use that bolt connector in more places, spend less time modeling and meshing my bolts and pins. Additionally, in simulation, we can now calculate the free body forces in not only our static studies like we could do in the past, but also now in nonlinear static and dynamic studies. So I can get this kind of detailed free body information even in these complex studies. So these enhancements, like I said, they're just improving our ability to do simulation quickly, so we can do it earlier in the design process at less cost before we spend a dime on prototyping.